tell me one thing, Emil, where you were like, struggling most in the physics. Just give me a brief idea. So once I have the idea, right? So according to that, I will plan it out how I can, because only the pretty much 2 months, right?
Yeah,
So September and October, November and on mid-November, you have to write the exam again, right?
yeah,
So in these 2 months, we can cover up the portion, very well.
yeah. So I would say that I didn't practice a lot. So topical past papers I need to practice,
Okay.
as well as topics like waves and electricity, like the big topics. They were kind of difficult for me, the theory part. And in the exam, I saw my raw marks, and it was actually the MCQ which brought my grade down.
Yeah, the
So
MCQ, yes, yeah, yeah, MCQ is very lengthy, actually very lengthy, right? It's
yeah,
yeah, to finish that within the time, it's a big task.
yeah,
But paper two, the writing paper two, which is the summative kind of thing, that is okay. That is not that much difficult. You can able to finish within the time.
yeah,
But the paper one, which is topical multiple choice, right? They are
yeah.
having the around 35 questions, 30 questions, right?
40.
Yeah, 40. Sorry, 30 is
Yeah,
in the IB. 40 questions. So 40 questions. So those 40 question and the how about the electricity questions are always confusing,
yeah.
right? Because I've seen the many question. So there will be a small tricks which you have to use in that. And how about the mechanics?
Uh, the
How did
mechanics the mechanics part is mostly okay, but the Suvat equations and kinematics is a little bit difficult when the questions come. But now,
okay,
like I myself started studying also, so now it's getting a little okay. So
okay,
those topics are okay.
mechanics. Okay, so mechanics is kind of okay level, right? So what we will do is we will cover up this very quickly.
Yeah,
Whenever we do this start learning, so this will cover up very quickly. But mainly you are having the problem with the waves and electricity,
yeah,
right? Okay, so electricity is waves and electricity both are confusing. The problem with the waves is that they've in that in the phase they put the large amount of portion.
yeah,
So that's why to cover up that we you need time. You cannot cover into the 1 month or 2 months since you have learned it before. So we can able to do it as fast as possible. And electricity is the heavy topic,
yeah,
right? There are the many questions in the paper two, and many questions in the paper one,
yeah.
right? And you are not writing the alternative to practical,
No, we're
or
doing
is
the practical paper three.
paper three you will do, right?
Yeah,
I mean, in the November, October, November, November, December, you will write the, you will
yeah.
do the practical, or you will write the alternative to practical paper.
I'll do the practical.
You do the practical, okay. All right. So then, Emil, what I will be doing is I'll be sharing my screen,
Okay.
and you have to see, right? And you have to tell me the pace, right? So because you and what about the A levels?
I will write those in May, June next year.
May June, right? May June next year, right? In the 2025.
Yeah,
Okay. Okay. So you are also learning that along with the A's,
yeah. But I'll
right?
mainly focus on that after my this reset
The
is
A's.
done.
Yeah, resetting is done. Okay. Okay. All right. And I think this A level portion you are doing into this school as well, right?
Yeah, but I don't think I'll be able to go to school because I have to do two resets. So I won't be going. So I'll miss a portion, but then I have to cover it up myself.
Okay. So you will not be going till the November, or
Yeah, yeah,
okay. So
mostly.
you will be able to do early, right? In the classes in the
Yeah,
daytime. So you will have the full day to revise, isn't it?
yeah,
Okay. That makes sense. All right. So you can see the white screen, right?
yeah.
So then see what I'm doing is I'm just taking the one topic of the waves, right, which is superposition. I'm not going to take that as speed is equal to distance over time, so that
Okay.
you already know because you
Yeah,
are done in the GCSEs also, right?
yeah.
So superposition. This is just for the demo, right? I want to see how much amount of portion you can able to grasp into the during the class. Also, I want to see the what pace will be suitable, right? Because if you are getting the things very grasping the things very quickly, so then I will go faster way, so then
Okay.
we can have the quick revision. And if I'm going the faster and if you are not understanding anything, so then we will reduce the pace and we will go the wave anyway, right? That graph will be drawn time against the displacement, right? It will be
Okay.
like a sine graph, it can be a cosine graph, right?
Yeah,
This also drawn against the distance and displacement, right?
yeah,
Here, x is displacement. So in the first graph, this will tell us the length of the one cycle, right? That is the
yeah,
time period. And in the second graph, if we are taking this, so that length will tell us the wavelength, right? Lambda,
yeah,
isn't it? right? This is t, this is lambda, and the wave speed is lambda over t, and 1 over time period is the frequency, right?
Yeah.
So similarly here, the superposition, we can have the any two waves, right? Any
Yeah.
two waves, no matter they have the same frequency, same wavelength or anything, right? There should be a two waves, and that those waves do the superposition. Superposition, that meaning is the addition, right? We are combining them. So for example, let's say we are having the water and we are having the milk, and we are mixing them, right? So then there will be some result, isn't it?
Yeah.
So same thing here. We are having the one sound wave, we are having the another sound wave, and they are meeting in a particular in a one region, right? And in this region, they will do what? They will do superposition. That means that they are going to be aided. But now the question is that, do we aid directly or do we aid their displacement? Because there are the two things. One is the distance and the displacement. So what we do is we do the vector sum. Vector sum, that means that we do have to care about the directions, right? Where the particles are moving or where the waves are moving, right? So it is a vector sum of some of the displacements of the two waves, right? Two or more waves, right? But for the superposition, the frequency and wavelength may or may not be same, right?
Yeah.
May or may not be same. But if we say the diffraction grating or superposition, for that the frequency has to be the same specifically, right? We will say those are the coherent waves, right?
Okay.
Do you remember the definition of the coherent sources?
It's they have the same frequency and
Okay,
the same wavelength, I think.
all right, correct. That is true. That is true. There is a one more point about that. If you
They're
can,
emitted from the same source.
okay, that you can, yeah, that can be also be. Let's say, what if we are having the two sources? There can be two sources also.
If it's two source, then they need to have the same frequency.
Yeah, the frequency and wavelength has to be the same. One more terminology we use, which is the phase difference, right?
Yeah, constant
Yeah,
phase.
so there should be a constant phase difference initially, right? At the same time. So let's say we are having the two source. One source is at the phase difference between them is zero, and let's say the pi radian, right?
Mm.
So all the time they are emitting the frequency, or all the time they are emitting the wave. That should be a pi radian, right? But at the time when they are meeting when they are superimposing in a particular region, the phase difference can be variable over there. That's why we can have the maximas and minimas, right?
Yeah.
And that superposition we will say the interference, right?
Yeah.
Okay. But in the case of superposition, we do not have to care about the whether they are the same frequency or wavelength, right? They may be same, they may not be. So let's say one wave here is t, here is x1, and this is x2. And if they are say doing the here I've specifically said the vector sum, right, of displacements, isn't it? And that produces the resultant displacement. So whenever in the question, sometimes they ask the definition, right, for one marker or two marker. So for one marker, you can directly say the vector sum of the displacement. But if it is a two marker, then you have to also say that produces the resultant displacement specifically. Remember,
Okay.
don't mention the amplitude. If you are saying the vector sum of the amplitude, so that will be marked as wrong.
Okay.
And if you see in the marking scheme, sometimes they will write in this double bracket, right, vector or
Yeah.
displacement. So this is the key term, or we can say the keyword that should be in the answer. So if it is
Okay.
missing, then even though you are having the correct answer, they will not award you a point. So we will be take so whenever we do the since you have not done the topical past paper question in the proper way, right, as you mentioned. So
Yeah.
whenever we will do the practicing, so we will be take care about that also,
Okay.
because that is important. Let's say if you are writing, and if these keywords, the way you are writing the answer, that is fine. And if you are adding the keywords and it is giving you the 5 more extra point, then it will be a beneficial to us, right?
Yeah.
Okay, all right. So t and x1, right? So this, let's say I'm taking just simple this kind of wave. This is the one, and second is like that. Okay. So see, their frequencies are different, right?
Yeah.
This is 1 second, 2 second, 3 second, 4 second. Here 2 and here is 4. Okay. So when they do the superposition, so we have to add their displacements, right? So if we are saying displacement, so then we have to take with the sign, isn't it?
Yeah.
We cannot just say the 8, right? X1 and X2. So this is Y, let's say. So for one, here it is. See, here I've taken the square waves. They can be any, the two sine waves, two cosine waves. It is
Okay.
depending on to the question. It can be a irregular kind of wave also. Right.
Okay.
So see here, let's say if this is one, one. So when they meet, so when they're, let's say the source is one here, sound source, and there is another sound source here. The waves are coming from this, waves are coming from this, and here we are looking the superposition, right?
Yeah.
Right. So that superposition will be seen. Like that resultant motion of that particle will be represented by this graph. So now
Okay.
see here it is one, and this is one. So one and one together will be two, right?
Yeah.
Right. Now this is minus one, this is plus one, right? So minus one plus one, so we have to take with the sign because it is a vector addition, vector sum. So minus one plus one, it will be zero, right?
Yeah.
Here it is a plus one, here it is a minus one, right? So plus minus will be zero, right? Plus one minus one, it will be zero. And then this is minus one, this is minus one. So minus one will be minus two or negative two, right? This is the resultant displacement,
Okay.
right? In the interference, we will say that there can be a constructive or destructive, right? So
Yeah.
if there is a constructive, so they need to be in the same phase, right?
Yeah.
But I will give you what is the same phase, what is the different out of phase, right? Because
Okay.
if that thing is clear, same phase difference and the path difference. If these two things are clear, then after the superposition, that is around the 60% of the portion of the wave, those will be very clear to you because
Okay.
all the answers we will write in the exam. Even if you talk about diffraction, you have to write in the terms of the phase difference and path difference.
Yeah.
Standing waves, same. Interference, the same, right? But for interference or for diffraction and standing waves, the waves should have the same frequency and wavelength and constant phase difference. But their amplitude may or may not be same, right? Amplitude, it doesn't matter, right? They can have the same, they can have the different, right?
Yeah.
This is clear. Okay.
Yeah.
Now I will come on to that phase and phase difference because that part is very important. Phase and phase difference. So if the phase, we will talk about to the individual particle. So if we are saying the one particle, how it is oscillating. So for example, let's say we are having this spring, right? And we are pulling it. So it will oscillate into the vertical plane, right?
Yeah.
Suppose what we have done is here, if this is the original length of the spring, you think about into the vertical plane, right?
Yeah.
That will give you the better understanding of that. If you are pulling if you are pulling in, then we are releasing, right? So
Yeah.
it will oscillate back and forth, isn't it? But
Yes.
this is the one case. Second case, if it is unstretched, right? This is just the mass is connected to that. But we are giving the a jerk or we are applying a force on it, right? And by that force, we are making it to oscillate back and forth.
Yeah.
So both are the different situations, right? In the one case, the particle is starting from the max point, and second situation is that the particle is starting from zero, right? Isn't it? So that we want to represent mathematically, isn't it? So that we will define by the phase, right? So phase will tell us from where the particle is starting, right? The
Okay.
initial orientation of the particle in terms of angles. And
Okay.
phase difference, it will be with the comparison between the two or more, right? If we are the two particles and we want to compare, then it will be a phase difference. So phase difference is the angle equivalent of starting position of the particle.
Okay.
Let's see. Here it is starts from zero. Here it is starts from the max. So if it is starting from zero, so sine graph will be sine graph starts from zero, right?
Yeah.
So for that we can say sine omega t or sine theta, right? Or let
Yeah.
me say the omega,
Yeah.
sine omega t, right? Then for this, it is starting from the max, so we can say x is equal to x0 cos omega t, right? But now the thing is, if we write both in the terms of sine, so this x is equal to x0. This sine omega cos theta, I don't know whether you have learned in the pure one math or not. X0, sine 90 minus theta is cos theta, and cos 90 minus theta is sine theta in the unit circle. Right.
No, I don't.
Okay. Okay. So this can also be written as sine 90 plus theta or 90 minus theta, right? Pi by 2 plus theta. So this pi by 2 is technically the phase difference, right? If you do compare with these two.
Okay.
Okay. If phase difference will with the comparison with the two particles or two positions, right? But phase
Okay.
It's just for the one particle. Or if you
Okay.
want to see that analogy in the circle, so here we are saying the one particle starts from here, so that is having the 0 degree, right? Zero phase. But one particle is starting from max, right? So that
Yeah.
is having the 90 degree, right?
Nice.
Or pi by 2.
Yeah.
So so the phase of this phase will represent by phi, this phi. So 90
Yeah.
degree or pi by 2. Actually we write in the radian, so pi by 2. And
Okay.
phase of this is 0, right?
Yeah.
But what is the phase difference between the particle number 1 and 2? So that angle difference, right?
Yeah.
That is the phase difference pi by 2
Okay.
or pi, right?
Okay.
But this is when by the position, by the circle. But actually, the question they will test to us on the waves, right?
Yeah.
How we can see in the wave. So
Yeah.
let's say this is the one wave because we are talking about to the phase difference for relative to the two particles, right? So we have to take the two waves, isn't it?
Yeah.
So this is let's say the first, and second is something like this. Second is something like this, right?
Okay.
So then see, we have to see their same position. That meaning is the initial orientation point. This is the initial orientation point. Here it is the orientation point, right? So
Yeah.
then angle difference between them, right? That is the angle difference.
Yeah.
This angle difference will be the
Phase difference.
angle, yeah, equivalent, right? Is the phase difference. But here from here we can get these both the waves are in the with respect to the time axis, right?
Yeah.
But we are looking for the angle. So we know that the one full cycle is 2 pi radian, right?
Yeah.
This time will be proportion of that cycle, isn't it? So
Yeah.
that proportion divided by the full time period and multiplied by the 2 pi radians, then it will be a phase difference. So phase difference will be the difference in the time delta t over t times 2 pi radian. Or it can be, see here in the beginning I said that the waves can be drawn into the two ways, right? One is the time against displacement and second is the distance against displacement, right? So
Yeah.
it could be a displacement time graph, displacement distance displacement graph also, right? So
Yeah.
in that case we will be having the distance, right? So that we will say delta x divided by full wavelength time 2 pi radian.
Okay. So
Correct.
this full wavelength will be the wavelength of one wave, right?
Yeah, one entire cycle, correct. This.
Okay. And the time
Yeah,
period also is for one wave.
one cycle. So if we are having actually that should be time period, and if we are having here is the position or distance, right? That's a position or distance, and here is the displacement. Let me write the distance so it will be the same. In that case, we're gonna have the wavelength.
Okay.
Okay. And actually you need to know this equation and this relation.
Okay.
This is not need to know, but the way to calculate the phase difference, you should have to know
Yeah.
because this generally we are going to use in the multiple choice question,
Okay.
right? If you remember from the past paper, so there were many questions you will find on this concept,
Yeah.
the phase difference, right?
Yeah.
But mainly they will give you with the circle, with the wave.
Okay.
But this diagram, this and this thing, that will give us the actual understanding about how the phase and phase difference work, right?
Yeah.
Okay. And if the phase difference, let's say delta x, sorry, this delta x, here this delta x, right?
Yeah.
Later on I will tell you this video we will say the path difference,
Okay.
right? Path difference, basic, yeah, actually how we can calculate this path difference. Let's say the source 1 is here, source 2 is there, and here is the point at which we are looking the superposition, right? This is the
Okay.
point, just a point. So the wave will travel a distance from here is x1, the second wave will travel a distance from here, so this is x2. So this difference in the distances traveled, difference in distances traveled is equal to the path difference, right?
Okay. So phase difference is for one particle, and path difference is for the entire wave.
No, the phase is only for one particle. Phase difference, we will compare the two particles or
Yeah.
two waves. And path difference is also with we are comparing the two waves.
Okay.
right. That's why we have the relation here, phase difference and path difference.
Okay.
Right. So the phase and path both will be a relative to the two positions or two waves.
Okay.
Right. And it will be just in the case of phase difference, we will say the angle equivalent, right?
Okay.
And in the path difference, we will say the distances, because suppose let's say you take the two smallest speakers, right?
Okay.
And in the two different corners of the room, and you will put the one receiver in between the room, right? So
Okay.
measuring the distances from the sources, it will be much easier than to the calculating the phase difference, right?
Yeah.
So then measuring the distances, so which means that we can find out the path difference easily just calculating the distances rather than calculating the angle.
Okay.
So then all the things which are based, the interference, diffraction, standing waves. So in those we will mainly calculate the path difference. By the path difference, we can come to know what is the phase difference because we have got the relation,
Okay.
right? And the superposition doesn't have to do anything with the frequency and wavelength. They can be any. But if we talk about to the interference or constructive superposition or destructive superposition, then specifically we will say the same frequency, same wavelength, but constant phase difference.
Okay.
Right. Okay. Also, one more thing here is these kind of question they frequently ask in the CIE, right? The Cambridge AS physics. So what they do is, let's say there is a one pulse we are sending from this side, another pulse from this side, right? You must have seen these kind of examples, right?
Yeah.
So right. So when they meet, right? When they are meeting, right? So when they are meeting, so what they will do here is the positive side. This is also positive side. So they will be producing the resultant, right? So they will when they produce the resultant, so it will be getting doubled, right?
Yeah.
Right. So it will be 2A. Sorry. But once they cross over, right? So then it will be this. Right. The moment they are meeting to each other, then they produce the 2A amplitude, 2A displacement. So the particle which is over here, right, at this position or in the rope, that particle will be lifted twice up, right?
Yeah.
Okay. And you must have seen this example as well. This this is right, this is left. So when they are meeting, so they will cancel out to each other. But once they cross over, it will be like that.
Okay.
Okay, right. So this is also the way to learn the superposition.
Okay.
Okay. Okay, so Emil, I think the time is well, right? It's a 30 minutes demo.
Yeah.
So tell me one thing, you were able to understand these things, right? Whatever I was explaining to you.
Yeah.
Right. Second, the pace. That pace is okay, or should I go faster or slower?
Now the space is okay.
The pace is okay, right? So you can able to grasp the as many as things, right?
Yeah.
And also the thing is you are going to write in the October, November. So we will mainly focus on to the topical past paper questions
Yeah.
for learning that. Let's say in this month and next month we are covering the entire syllabus. Suppose we are covering that. So we will only focus on to the exam oriented questions.
Yeah.
So we will take at least 1 or 1.5 month buffer to do the practicing of the past papers only. The
Okay.
full skill, right? Not the individual topic.
Yeah.
Okay.
Okay.
All right then. Yeah.
Thank you.
Yeah. Okay, Emil.